This is the pre-AP geometry review. We're breaking the review into several sections for the videos because the way that Mr. Long teaches is not the same way that Ms. Costanzo and Ms. Graber teach. So we're going to do the problems that involve finding pieces in one video and the problems that involve what is this thing in another video. So number 9, we know this thing is a parallelogram. Well, that's good. Parallelogram means that we have opposite sides congruent to each other. So that's easy setup. And for the sides. For the angles, because this is a parallelogram, we know that this triangle angles add up to 180 degrees, which would give us measure of angle AFD. So that angle (97 degrees). CDF is a linear pair with that, or this angle plus this angle, which gives us 83 degrees. FBC is alternate interior angle width of 34. We know that the sides of this parallelogram are indeed parallel, so FBC is also 34. BCF, similarly, is 49 degrees. For number 10, we know this is a rhombus, and we know that in a rhombus, the diagonals bisect the angles. So that means that measure angle 1 is congruent to measure angle 2. We also know the diagonals are perpendicular, so angle 3 equals 90. Here we need to keep in mind that it could be the negative version as well, because there's nothing to say that the angle becomes negative if y is negative. As for AF, diagonals of a rhombus, because it's a parallelogram, bisect each other. So if AC is 15, AF is 7.5, or 15 over 2. Problem number 11. We are given a lot of pieces of information about this. We know that rect is a rectangle, which means we have right angles on all the corners. We know that TCAO is an isosceles trapezoid, so these angles are congruent to each other. Also, these lines are parallel, which means that line is also parallel, which means that we have corresponding angles right there. RHOT is a rhombus, which means every angle is being bisected by the diagonals, and we have right angles in the corner. CA is 65, TH is 62, and because these diagonals bisect each other, that means that each half of this thing is 31. Now it's a matter of finding all the missing pieces. RE looks hard to start with, so let's just take stock. We have a bunch of these sides. PT we've already found is 31. Because TCAO is an isosceles trapezoid, we know this side is also 65. And then we can pull this triangle out of the rhombus to deal with separately. Because at some point we do need to find OP in order to find OR. That's a simple Pythagorean theorem. Which my calculator tells me we're going to keep that written out as a long decimal. But in the diagram, I'm just going to call this 57.1. OR is going to be 2 of those. And a rounded answer. Angle RTO we can find because we can find this angle in this triangle and double that because the rhombus angles bisect each other. So we know the adjacent and the hypotenuse. We're going to use cosine. Which my calculator tells me is approximately 61.5 degrees. Doubling that for angle RTO, you get 123.03 degrees. We already have OPH. In fact, because this is a rhombus, we have all these sides as well. And because RECT is a rectangle, the opposite side is also 65 degrees, or 65 units. We have enough information to find the angles inside the rhombus. We know that is 61.5. Subtracting that from 90, we get approximately 28.5, realizing that's a little bit rounded of a number. And this one is also 28.5. All of the angles around here, point T, add up to 360 degrees. Which leaves (146.97 degrees for that angle. Because this is an isosceles trapezoid, that was also 146.97. And these then are 33.03 degrees. Inside this right triangle, we can find that this angle is 56.97 because the angles add up to 180 degrees. And that enables us to find the measure of angle ARO. 28.5 plus 56.97. 85.5 degrees total. This is going to be alternate interior with this one. So ECR is also 85. Sorry, ECR is also 56.97, or approximately 57.0 degrees, if you're rounding to one decimal place. So we're left with RE and OA. RE we're going to need to find to be able to find OA, and I'm going to need to erase this work to have room to draw my new triangles for more trig. Keep in mind that the right angles in a rhombus are in the center. In a rectangle, they're in the corners. We want to find that because that is RE. So we know the opposite. We want the hypotenuse. We're going to use the sine of 33.0307 equals 65 over x. Keep in mind I'm using more decimal places than I need to round to in the end, so that when I type this into the calculator, it's not going to mess up my answers. And I get that x and RE is 119.2467. Final answer, 119.25. And here's the fun part. OA. We're going to chop this off into manageable pieces. We know that here to here, because this is essentially a rectangle now, this is a rectangle now, we know that this side is also 119 point about 25, but I'm remembering that number there. These triangles are now the same because of HL, or angle, angle, side. So we only need to find one of those lengths. So if I redraw this triangle out here, that's 65. This is 33.03. And I would like to know this now, which means I have the hypotenuse, I want the adjacent, I'm using cosine. Multiply the 65 up. And you get y equals approximately 54.4946. Add up everything you see from O to A. And you get a total of 228.24 when you round to the nearest hundredth. Except that that goes here. Proving something is a parallelogram can be done several ways. One way opposite sides congruent, both pairs. One way is opposite sides parallel, both pairs. Or we could do one of each, which we'll get to in a second. Or the diagonals bisect each other. Doing angles with coordinates is annoying, so opposite angles being congruent or consecutive angles being supplementary is not an approach I'd like to take with this. So the opposite sides of this thing would be AB is across from CD. and AD is across from BC. So if we're doing opposite sides are congruent, we're essentially doing Pythagorean theorem. So from A to B, 5 on the x's and 2 on the y's, square rooted. And from C to D, that's 5 on the x's and 2 on the y's, which also equals square root of 29. So yes, that set of opposite sides is congruent. I'm going to check the other set now. From BC to AD. From A to D, along the x's is 7, along the y's is 7. From B to C, along the x's is 3. I'm sorry, I was mistaken. Along the x's from A to D is also 3. From B to C on the y's is 7. So those two sides are parallel as well. We have two pairs of opposite sides parallel. That gives us a parallelogram. Now let's look at opposite sides being parallel, not congruent. From A to B, slope, we're going up 5 on the x's, and we're going up 2 on the y. For CD, we are going from 3 to -2. That is backwards 5. And then -1 to -3. That is down 2. We have two the same slope, so the lines are parallel. The next set, AD and BC, from -5 to -2 is +3, and from +4 to -3 is -7. Note that these are the same numbers we're seeing when we are doing the Pythagorean theorem with these as well. Also why I feel like these two methods are a little more tedious than the other ones. From 0 to 3 is over 3. From 6 to -1 is down 7. So we have both sets opposite sides parallel. That proves that it's a parallelogram. What I probably would have done at this point is to say that all you really need is one set of opposite sides congruent and parallel, which we've now done twice. We have that set, and because these numbers are the same as these numbers here, I would probably just stick with that method if I'm going to do the congruent sides, parallel sides options. But if you're not comfortable with distance formula, Pythagorean theorem, or if you're not comfortable finding parallel slopes, then stick with one of the other column methods. The third method, and what I think is probably the fastest and most efficient method, is to find out that diagonals bisect each other. What will get the diagonals to bisect each other is if they share a midpoint. The midpoint of one, if the midpoint of one is the midpoint of the other one, that's where they intersect, and if they intersect at each other's midpoints, then they bisect each other. So we need to look at the diagonals now, which are AC and BD. So the midpoint of AC is the average of the x coordinates and the average of the y coordinates. Forgive me, it's been a long week. So that's midpoint of AC. Hopefully that is also the midpoint of BD, because if it's not, we messed up somewhere in this giant problem. So the average of the x coordinates and the average of the y coordinates. And they are the same coordinate. Therefore, the diagonals bisect each other. Therefore, it's a parallelogram. Now, on the test, you don't need to do every single one of these things. You need to pick an option. You can either pick column A, column B, column C, or one of these two rows. And it doesn't matter which one you use, as long as you're comparing both sets of opposite sides. Knowing this is an isosceles trapezoid, I'm going to do that same thing we did in that earlier problem and make that rectangle in the middle. I know that the width of this rectangle is A. I know that the width of this part of this triangle on the bottom is A. And if we need to get to 4A overall, there's another 2A right here, which means from here to here is 3A across. Also knowing that the trapezoid, the sides are parallel, this has to be the same height as this. So 3AC is going to be the height for that one. For the rhombus, I know that this entire side has to be A plus B. So if I'm starting at the origin, or at the y-axis, the x-coordinate is going to be A plus B. And the y-coordinate, because these need to be parallel as well, has to be C, which doesn't necessarily make this thing a rhombus, more like a parallelogram, but I don't believe we were given enough information to do otherwise. For the parallelogram for 32, it's really the same problem as 31, so I'm not going to redo it. The trapezoid, similarly, I'm going to break this down into manageable bits, two triangles and a rectangle. It's isosceles. I know that this thing is A plus 2B. I'm going to make a guess and say that's A, and here are two B's. We're not given a height here, but it has to be the same height, so I'm going to make up a new letter because we aren't given enough information to figure out what that height is otherwise. So the width of this is B, and the width of this is B plus A, or A plus B. That concludes this section of the review. Thanks for watching.